guys, welcome to Scale Guru's another tech episode. Today I'm going to be starting a new series called as Snapdragon Sundays, where I'm going to be talking about Qualcomm Snapdragon based technologies, how your smartphones work, how your smartphone processors work, how they behave, what about the battery life, the performance, and all that kind of stuff. Let's dig into it for today. So today we are going to talk about Snapdragon's heterogeneous multiprocessing. Why HMP is important. So HMP is important because heterogeneous multiprocessing, as the name suggests, is basically trying to kind of splitting up things into different modules and then working on them instead of having a homogeneous way of doing it, basically collectively doing it. So as you know, all the smartphones are hugely impacted by the apps that have been running on the background all the time on your phones, and these processors consume a lot of battery and have to be optimized in a way that you get the max battery life out of your phone. So how are these apps handled, and how does the processor actually effectively manages all these apps? Let's look into it. So the architecture that Snapdragon uses is basically, let's say if your phone has like 8 different cores, then all those 8 cores are divided into 2 different parts. Let's say the first cluster has 4 cores, let's say A15 of A15 cores. So A15 or A7 basically means like there are 4 cores that operate at more than 2 gigahertz, and the other 4 cores operate less than 2 gigahertz. So this gives a nice balance of high intensive tasks and low intensive tasks to handle effectively without losing more battery. So what Linux scheduler does is basically it creates 2 different clusters, and both of these clusters couldn't be active at the same time. So you have to have one cluster active at a point. For looking into this big dot little architecture here, task 1, task 2 are heavy tasks which have been already assigned to A15, which can handle all the tasks efficiently. Task 3 and task 4 are still light tasks but are still being pushed into the bigger cluster from the little cluster. So you can see task 3 and task 4 in the little cluster are switched into the bigger cluster as and when required, but the only disadvantage here is only one cluster could be active at a time. So to resolve this, Qualcomm has come up with a completely heterogeneous multiprocessing Linux scheduler, where you have all these 8 cores independently acting as their own core. So let's say if task 1 and task 2 were highly intensive, so they are on the 815 cores, and task 3 is on was on the A15 core initially, but once the task has been identified that this task is not that intensive, it's in turn moved to the A7 core. What this does is basically has your impact on the battery life. Since all the cores are not active all the time, the battery is not being used, only those cores are active which of the cores are being used by your tasks. So this helps more faster processing and effective processing using heterogeneous multiprocessing technology. So to give a quick demo of this technology, let's look into the app. Let's look into an app where you called as CPU-Z. What CPU-Z app does is basically shows you all the cores and the frequencies it's operating currently on your phone. So I'm going to be using a software called A-Power Mirror. So this is a software where you can actually mirror your Android device on your PC. So as you can see, we have our phone here. Now let's go into the CPU-Z app, and you can see all the 8 cores running, and this is the minimum clock speed and the maximum clock speed here. And let's wait for a couple of minutes to see all the cores working. Let's try it again. Yeah. So once you see this, so Qualcomm Snapdragon 835 was implemented with big dot little HMP 2 cluster architecture. This is what I explained just a little while ago. that there are two different clusters operating at two different frequencies, and both of them are not active at the same time. So as you can see CPU 0 to 3 has the same clock speed, and CPU 4 to 7 has the same similar clock speed, and they have been clustered into two different clusters. But Snapdragon 845 is being speculated to be able to handle HMP, complete 8 different cores acting independently. So this is it for this video. I hope you like this video. This is a short video on how HMP is used and how HMP affects your battery life, and how's the scheduling is done on your smartphone. I hope you like the video. If you like the video, please share and subscribe.